In this video, I'm going to continue the discussion of types of chemical reactions, looking specifically at replacement and combustion reactions. So remember there are 5 basic types of chemical reactions: synthesis and decomposition, which we've talked about previously. And then today we're going to focus on single replacement, double replacement, and combustion reactions. So single replacement reactions are also known as single displacement reactions. And in this reaction, one element replaces a similar element, which is found or starting out as a part of a compound. Single replacement reactions are exothermic. They release heat. And your reactants are always going to be a pure element as a solid or a gas, and then a compound in an aqueous solution. Then the products are the different pure element and a different aqueous solution. In one type of single replacement reaction, a metal replaces another metal. So in this reaction shown below, we have aluminum metal and copper sulfate, and we end up with aluminum sulfate and pure copper metal. So our pure metal on the reactant side is aluminum, and on the product side is copper. The second type of single replacement reaction has a metal replacing hydrogen, and the hydrogen is coming from water. So this is a common reaction between our group 1 metals, such as potassium. And potassium basically is going to affect one of these 2 hydrogens found in water and release it as hydrogen gas. Since the reaction is exothermic, you can end up with a flame showing up as the hydrogen gas actually ignites because of all the heat energy. And then we have metal replacing hydrogen, but not in water this time, but in an acid. And so our reaction of magnesium with hydrochloric acid, which some of you did in lab, will produce hydrogen gas again, this time without a flame, and then magnesium chloride is left behind in aqueous solution. Another type of single replacement reaction doesn't involve the metals, but it involves the halogen elements, or the group 17 elements. And they will replace each other as long as the replacing element is closer to the top of the column. So fluorine will replace everything below it, chlorine will replace everything below it, and bromine can replace iodine. In the picture here, we see chlorine gas being added into a solution that contains bromine, potassium bromide. The bromine is starting to appear here in a change of the liquid color to a browner color. And then actually the substance in the bottom is something that just the bromine will dissolve into. So it eventually just dissolves into that layer. Determining which elements, which metals will replace other metals, can be seen in something called the activity series, which is just a list of which elements will replace other ones. And just like with that list of halogens, ones that are on the top will replace elements below them. And so you can use an activity series to predict if a single replacement reaction will even occur. Double replacement reactions, or double displacement reactions, see the positive ions of 2 ionic compounds changing places to form 2 new compounds. Your reactants are always going to be 2 aqueous solutions, but the products might include a precipitate, a gas, or an aqueous solution. So you're starting off with 2 aqueous solutions, but you can end up with something else. The reactions for double replacement reactions might be exothermic or endothermic. It really depends on what's being produced. One type of double replacement reaction, when it produces a precipitate, is illustrated by this picture down here, where 2 clear aqueous solutions, potassium iodide and lead nitrate, are combined, and you see this yellow precipitate forming. That is your lead iodide compound, and then in aqueous solution you have the clear potassium nitrate is still present. Precipitates form when this new compound is insoluble in water, and so it can no longer stay in solution, it has to fall out. There are various solubility rules that can be used again to predict if the product of 2 aqueous solutions would include a precipitate. The second type of double replacement reaction produces a gas. So our illustration here is showing sodium sulfide mixing with hydrochloric acid. So gases are produced when an acid is combined with a compound that contain a carbonate ion, a sulfide ion, or a sulfite ion. In this case, we have a sulfide ion because it's just the sulfur, and you can see the little bubbles of gas being produced here in our third test tube. And then we have a certain type of double replacement reaction, which is known as a neutralization reaction. And this happens when an acid combines with a base, and you get out water as one of your products, and then the two leftover ions combine together to make a salt, which is just an old-fashioned word for an ionic compound. The properties of the acid and the base, the pH, the low pH for the acid and the high pH for the base, are actually removed by this reaction. You end up with a neutral pH because water has a neutral pH. And so that's why it's called a neutralization reaction, an acid-base reaction. And then we have combustion reactions, the final type. In a combustion reaction, a substance reacts with oxygen and it produces carbon dioxide, water, and then heat and or light. You can have many substances that react with oxygen that produce other things. Those are not combustion reactions, but if you get carbon dioxide and water out of it, it is a combustion reaction. In real life, many combustion reactions don't have enough oxygen present, so that you end up with things like carbon monoxide or other carbon compounds, things like we call soot and ash, will form. But in sort of the purest sense, you have just a reaction between the carbon dioxide and the fuel, like we have with our gas stoves. These are different than what you have burning in your fireplace. Many combustion reactions occur with a hydrocarbon as the fuel. Hydrocarbons are compounds that only contain hydrogen, as you see from the first half of the name, and carbon. That's pretty straightforward. And hydrocarbons release large amounts of heat energy and light energy. So our hydrocarbon example, we have some structural models of here. You see they're just a carbon chain with hydrogens attached on every available bond space. Propane, which is burned in many of our grills, for those people who like to grill out, has the formula C3H8, so it is a hydrocarbon. And gasoline, another hydrocarbon, has a formula of C8H18. So why don't we do some product prediction? Let's see what we have here. We've got strontium chloride and silver nitrate, two aqueous solutions. So this tells you that it's going to be a double replacement reaction. And so we're going to replace our two positive cations are going to switch places. We're going to end up with silver chloride and strontium nitrate. And I just know that the ion formulas by heart, so I can write these out for you. I expect you to use your periodic table of ions. Solubility rules suggest that most silver compounds are insoluble, so it's likely we would have a precipitate in this reaction. Our second reaction has zinc reacting with hydrochloric acid. This is a metal and an acid, and so we're going to get a single replacement reaction. The zinc is going to replace the hydrogen, and so we'd end up with zinc chloride and produce hydrogen gas. Our third reaction has HCl, again, hydrochloric acid, and magnesium hydroxide. Hydroxides are bases, so this is an acid-base reaction or a neutralization reaction, so a special type of double replacement reaction. Remember, those make water and then a salt, an ionic compound from our two ions, the magnesium and the chloride, so those would combine to make the ionic compound. And then our final reaction, we have a hydrocarbon, methane, CH4, reacting with oxygen, and so that's going to produce carbon dioxide, water, and then, of course, some heat and some light. So this is our combustion reaction. Just write combust here. So that's the overview of the replacement and combustion reactions, the final three types of chemical reactions.